In this video, I'm going to show you how to create a stem and leaf plot. Stem and leaf plot is also known as a stem plot. Now, why it's called that, you will see that by the end of the video. I'll explain it as soon as we get there. All right. So in our last video, we talked about a dot plot for ages of students in my class. Here is the same data. You have the ages of all my students. Now, in order for a stem and leaf plot to work, the easiest thing to do is honestly to sort your data in ascending order. So I'm going to say, you could do this by hand, or you can use a tool like Excel. I'm just going to say sort and then select all the data that I want to have sorted. And there, it's automatically sorted. Now, here's how the stem and leaf plot works. You are going to, first of all, list all of the different tens values, and then we're going to list all of the ones values. So our lowest number is 17. That's in between 10 and 20, so it's in the tens. So I'm just going to put a 1 for tens. And then you have the other ages, 20, 21, 22, and 24 are ages 20 through 29. So they're in the 20s. So 2 is the tens place. You can keep going and do 3 and 4. In this case, we don't really need them. Here, I'll do, yeah, there we go. Your single digits from 0 to 9. Tens would be 10 to 19. 20s would be 20 through 29. And then 30s would be 30 through 39. Okay. Now here's how it works. For each value, you take all these tens values and you put the ones value after the tens that we have listed. So we have 2 17s, an 18, and 5 19s. So down here, look at this key. This indicates how we're going to do things. If you have a 1 and then a bar and a 7, then that means 17. Okay, so we have a 17. Okay, so there's a 17. Now, how do we indicate the next 17? Well, we put another 7 there. So there's a 17, there's a 17, we have an 18, and we have 5 19s. Okay, so this is a pretty nice way of doing this. This is known what we call the stem. This would be the base number that we're going to use, in this case, the tens place. And the ones, this would be called the leaf. These are the leaves. And these are just all of the different values that are within the range of that stem. All right, let's keep going. For 20s, we have 20 through 24. We have 5 20s. 20s is 2 0. And there are 5 of those. We have 2 21s. We have 2 22s, and we have a 24. All right, so there we go. There is our stem and leaf plot. We're missing a very important thing. You do not have to label this stem and leaf. That's fine. As long as you have this key, I'm going to move that up so it's closer. The only other thing that we're missing is a title. Ages of students in my class. And there we go. That is a stem and leaf plot. Why is this nice? Because when you have quite a few stems, this actually shows a rather nice distribution. Let me do another example and see if this makes sense. We're looking at salaries of random employees in our area. Okay, this first one has a salary of 52,000. The K means kilo or thousand. The second person has a salary of 79,000, 81,000, 95,000, and so on. We're rounding here. Okay, so just like before, we're going to sort. Now, I'll warn you, because of the K in my data, it's going to recognize that as a character, all of these as characters, not numbers. So it won't list them quite in numerical order, but you can see everything under 100 is in numerical order here, and the hundreds are above. So we'll make this work. That's fine. All right, here's my stem and leaf plot. Let's see. I'm going to give it a title. It's going to be salaries. I have my key. My stem is going to be 5. My leaf is going to be 2. And that would be 52,000. All right. Now let me just add a couple more lines here. The smallest number I have is 52,000. So that would be 5 would be my smallest leaf. My highest value is 109,000. So there we go. So this would be 50 something, 60 something, 90 something, 100 and something. If we had another line here, this would be 110, somewhere in the 110s. We won't need that in this case. All right. So for our salaries, let's go through. We have 52,000. So there we go. And that's it for the 50s. We have a 65,000. That's it for the 60s. 70s, we have a 70,000, we have a 71,000, 75, 77, 77, 78, and 79. Is that it? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, that's it. For the 80s, we have two 80s, 81, 83, and 86. So 80, 80, 81, 83, and 86. 90s, we have 94, 95, and 96. Hundreds, we have 102, 105, and 109. And from that, you can start to see there's a bit of a shape starting to be produced by this graph, showing what we call the distribution of salaries in this case. By far, the most salaries are in the 70s range, and quite a few in the 80s as well. So this would indicate the middle of my data, essentially, here in the 70s and 80s. So, and that's how you create a stem and leaf plot. Again, what's really critical here is a label and a scale, but in this case, instead of a scale, we got to have a key. The key is the scale that we're going to do. All right. Also notice that these lines are all perfectly lined up vertically. If they're not, then it starts to distort things and it doesn't look like a graph anymore. It kind of ruins it. So anyway, so here's a stem and leaf plot, and we have more graphs to come in the next few videos. Again, stem and leaf plots, I should have mentioned this before, specifically for quantitative variables. They don't really work well with categorical variables. They're for quantitative variables. All right, in our next video, we will look at a few other different types of quantitative graphs.